Hey everyone, I wanted to talk about this problem number 1 from the 4.2 homework. There's a little problem with it. I don't like the way that they asked the question at the end there. I want to clarify a little bit about it. So let's just take a look at it here. As you can see, consider the graph of the function 6x to the negative 1 power. This is the same as 6 divided by x. And if you look at the graph of the function, here's just for values of x greater than 0. The domain of the function is all real numbers except for 0. Obviously, at 0, we have a vertical asymptote. Notice as 6 divided by x, as you divide by a smaller and smaller value, that's going to infinity. So if we continue up this way, as x gets closer to 0 from the positive side, the function f of x is going to infinity. As x gets very, very large, 6 divided by x is getting closer and closer to 0. So we have a horizontal asymptote of y equals 0 going in this direction. Okay, so with this, on the interval from 0 to 2, and it's real important that we see the parentheses there, that means we do not include 0 and we do not include 2. The question is, which is true? Do we have both a local minimum and a maximum on that interval? Do we have just a local maximum? Do we have neither local minimum or local max, or do we have just a local min? Okay. So what I'm going to say here is, for this function here, there are no local extrema at all for this function. Remember, the definition of a local extrema is where on an open interval, the open interval meaning we exclude the endpoints, so 0 to 2, this interval right here where we're excluding the endpoints, is an open interval. And on that open interval, we have a local max at, say, x equal a, whatever point on that interval you want to say, if the value of the function at a is greater than or equal to all the other values in that open interval, then we have a local maxima. Local minima would be what at a that value is less than or equal to any other values on that open interval. Okay, so at no point on this graph do we have that. The function is decreasing for all real numbers greater than 0. Okay, so I'm going to say right now that it has neither a local minimum nor a maximum. Now, does it have a maximum or minimum? Because that's not the same thing as a local max or local min. On the interval from 0 to 2, we don't even have a local a max or min. And the reason is we don't include 0. Obviously, we can't because of the vertical asymptote. And obviously, there's no maximum value, because if you say the maximum is, 1,000,000, well, I can choose x close enough to 0 so that 6 divided by that number is more than 1,000,000. And if you say it's 1,000,000,000, I can find a value of x such that 6 divided by x is more than 1,000,000,000. I can keep doing that forever. There's no maximum. We say, well, what 2? I can see f, the value of the function at 2 is what 6 divided by 2 is 3, right? It's 3. So isn't the minimum, well, 2 is not included, so it can't be 3. You might say, well, then the minimum is just the number that is less than 3. What's the number less than 3? Well, got a problem with that, right? When we talk about the real numbers, we're talking about a continuum. And the real numbers don't have a property. They're not discrete. You can't list them. You can't enumerate them in a list. Okay. There is no number, no greatest number that is less than 2. There is no greatest number that is less than 2. Okay. Some of you saying, well, 1.9999 forever. Okay, well, hate to break it to you, but that is the number 2. If you want to talk about that, we can explain more about that in a personal conversation. But if you pick any number, you say this number is the largest number less than 2. Okay, well, if that's the case, I will take that number and I will add it to 2, and I will divide that sum in half, and I will get a number in between the two. You see, I can continue to do that process. Real numbers are weird like that. There is no nearest neighbor for any one real number, and that's mind-boggling. But that's the case. Okay, bottom line is there's neither minimum, local minimum, or maximum, and there's no max or min. Same thing for the second one. We're just changing the interval from 1 to 3. We're shifting it from 1 to 3. Open interval, we're not including 1, we're not including 3. Still no local max, no local min, and no max or min either. Now, what's different about this next one from 1 to 2? Well, for one thing, notice brackets, we're including 1 and 2. Okay, now this interval will have a max and a min because we're including the endpoints. So at 1, at 1, what's the value? 6 divided by 1 is 6. 6 is the maximum because we're including that. Before, these intervals did not include, this interval did not include 1. So 6 was not a value, an output to the function on that interval, but it is here because we're including it. At 2, 6 divided by 2 is 3. The minimum is 3. So we have a maximum and we have a minimum, but we still do not have a local max or min. And I don't like that, this question, because what they want you to answer is that it's both a local min and a maximum. What they should have said is both a minimum and maximum, not local. Okay, it's a little confusing the way they've written that, and I don't like that. I know what they want you to say, but technically we have a max at 1 and a minimum at 2. And anytime you have a continuous function on a closed interval includes the endpoints, we're guaranteed to have a max and a min for any continuous function. Okay, open intervals, not guaranteed to have a max or min. But again, local max and mins are not necessarily maximums or minimums. They can be. Okay, in fact, on a closed interval, the max or min is going to either occur at the endpoints, like in this case, or at a critical point, right, where the derivative is 0 or undefined. In fact, that's true for any local maximum or minimum. If you have a local max or min, it has to occur at a critical point. And that's the key in this problem. There's no critical point, right? The derivative is never 0 for this function on the interval, everything greater than 0. The derivative is never 0 and never undefined. So there's no critical points for values of x greater than 0. And that's why there's no local max or mins. So technically, this is a bad question down here at the bottom. Sorry about that. But this is the actual answer. Both a local minimum and maximum is what they want, but that's not really good. So at any rate, I hope this helps with this problem. Let me know. Let me just check my answer here and see what happens. Make sure I'm saying the right thing. There it is. I've solved it in one attempt. Okay, so next question. Okay, so hope this helps with this one. If you have questions, I'm sure you do about this, please email me or make an appointment and meet with me.